Look at this chart mapping historical enterprise software productivity. For 2 decades, SaaS growth followed this predictable, linear path. Now, track the divergence. This exponential curve represents a structural break from traditional software capabilities. To understand this break, we must classify the outgoing era of generative AI as a passive utility. These systems act as sophisticated co-pilots, but they remain stagnant without continuous, manual human prompting to move from one task to the next. The exponential curve tracks the agentic frontier. Here, systems execute complex, multi-step workflows autonomously. The architecture connects individual nodes, allowing them to feed data into each other and course-correct without human intervention. Treating this transition as a software patch underestimates the economic impact. These systems represent a structural reconfiguration of industrial costs. Boardrooms must now reevaluate capital allocation to accommodate systems that operate without human oversight. This requires a complete rebuild of enterprise architecture over the next decade. This briefing will trace the mechanics of this transition. We will analyze the unit economics of autonomy, the integration dilemmas facing CIOs, the threat to legacy service monopolies, and the infrastructural gaps attracting early-stage capital. Directing capital toward passive tools when the market has moved to autonomous systems risks the misallocation of enterprise funding for the next 10 years. Historically, software ROI was measured through marginal efficiency gains. A tool was deemed valuable if it saved a human knowledge worker a few hours of labor per week. This diagram illustrates a standard enterprise balance sheet under that framework. Software tools represent a tiny fraction of total expenditure, while the dominant block remains the cost of human labor required to operate those tools. Agentic systems dismantle this ratio. Instead of increasing human speed by a fixed percentage, these systems deliver direct labor-equivalent output priced at the cost of cloud compute. Look at the mechanical shift in the ledger. As manual cognitive tasks are handed over to autonomous agents, entire sections of human labor expenditure move into the software column. Because cloud compute is significantly cheaper than payroll, the total cost shrinks. We define this financial mechanic as OpEx arbitrage, the capture of the price gap between baseline human salaries and API compute costs. CIOs used to tolerate multi-year software depreciation cycles. OpEx arbitrage allows for immediate ROI capture the moment a workflow is automated. Therefore, the metric for enterprise software adoption has shifted. We no longer measure time saved. The benchmark is now headcount equivalence. Capturing that OpEx arbitrage faces an immediate and unavoidable operational hurdle: the high-friction, complex chaos of enterprise software integration. This diagram illustrates the build strategy. Engineering custom agentic pipelines creates a complex architectural web. Stitching together disparate APIs and shifting foundational models rapidly accrues severe integration debt. Building internally grants an enterprise proprietary leverage over their specific workflows. However, maintaining that infrastructure requires machine learning talent that is currently in short supply. This drives many to the buy strategy. Relying on off-the-shelf vendor solutions allows the architecture to operate as a standardized black box. The advantage of the vendor model is rapid deployment. It slots into legacy environments, bypassing the internal engineering bottleneck. But that convenience carries risks. Offloading workflows to third-party agents often results in the loss of data privacy and surrenders algorithmic competitive differentiation to the vendor. Faced with a choice between engineering gridlock and vendor capture, executives are developing hybrid architectural frameworks. Competitive advantage in this space does not go to the firm with the most intelligent model. It goes to the firm that manages integration debt the most effectively. Scaling past internal IT strategy, we must examine the macroeconomic battlefield where this integration debt will be tested. The targets for displacement are trillion-dollar legacy sectors: B2B logistics brokering, insurance claims processing, and legal discovery. This flowchart maps the traditional value chain of a legacy service monopoly. It is linear and choked by numerous bottlenecks, all representing essential human cognitive labor. These industries rely on vast pools of intermediate workers. Their primary function is executing high-volume, rules-based cognitive tasks. When agentic disruptors enter this market, the value chain collapses. Autonomous systems sweep through the process, bypassing and deleting the human cognitive labor nodes. This distinction is vital. Agentic software is not designed to optimize these intermediate human workflows. It is built to bypass them. The financial consequence is immediate. The profit margin previously trapped in Mo's human labor nodes is rerouted, split between lowering costs for the end client and capturing revenue for the disruptor. As those nodes vanish, the traditional barriers to entry that have protected these legacy monopolies disappear. A challenger targeting an established logistics or insurance giant no longer requires the capital to hire thousands of workers. They only require variable compute power, scaled directly to demand. Legacy monopolies are structurally defenseless, primarily because they are fighting agile, compute-variable competitors with heavy, fixed-cost human armies. From a venture capital perspective, the question is where the next wave of capital deployment belongs. Investing in raw, foundational AI models is increasingly inefficient. The high capital expenditure required to train them, combined with rapid commoditization by tech giants, crushes margins. Look at the modern AI enterprise tech stack. The bottom tier, the foundational models, is reinforced by massive tech conglomerates. The top tier, the end-user workflows, is saturated with competitive SaaS applications. The vulnerability lies in the center. This middle tier is hollowed out. We call this the orchestration gap. To deploy autonomous systems at scale, enterprises require the technologies missing from this space: orchestration platforms to assign tasks, and communication protocols that allow disparate systems to interact. Most critically, they need deterministic guardrails. Foundational models are inherently unpredictable. Enterprises require strict security limits layered on top of them to monitor and halt rogue actions. The startups engineering this underlying oversight plumbing, the routing, the security, and the inter-agent logic, occupy the highest leverage niche in the ecosystem. While public attention remains focused on raw model intelligence, the next multi-billion-dollar empires will be the infrastructure companies that monitor and control them. We can map the agentic economic engine on a single dashboard: balance sheet, tech stack, and value chain. These form a tightly coupled feedback loop. OpEx savings flow directly into infrastructure investments, which then deploy outward to disrupt legacy value chains. Every enterprise is now forced to recalculate its base cost structures around compute rather than payroll. Navigating the build versus buy dilemma poorly exacts a terminal penalty. Getting trapped in endless custom engineering or locked into a rigid vendor ecosystem yields an insurmountable mountain of integration debt. Indebted legacy firms will find themselves exposed to lean, agent-native startups that scale output without scaling headcount. Competitive advantage no longer rests on the intelligence of the model, but on the robustness of the deployment infrastructure. The next decade will distinguish organizations by their infrastructure. Success will follow the enterprises that transition from managing human workflows to governing autonomous compute.